For section 7, we're going to look at when you can take the inverse trig functions. Now, if you think about the default sine graph, okay, why is this statement, these two statements together when you're talking about sine, problematic? Yeah, it doesn't pass the horizontal line test. Sine is that curve, that wave-looking function there, right? If I drew a horizontal line, it doesn't work. So what they do is they kind of cheat a little bit. They only look at it from negative pi over 2 to pi over 2. Because within that boundary, you hit every single possible y value between negative 1 and 1. And every x value from negative pi over 2 to pi over 2. They just ignore everything else. So when they say inverse sine, they're actually only talking about that much of your graph. Okay? So that since they're only looking from negative pi over 2 to pi over 2, the only sine values that matter are from negative 1 to 1. That allows it to be 1 to 1 and allows you to actually do inverses. Okay? Now, when you're doing right triangles, that's perfectly fine because the only angles you're looking for on a right triangle are between what and what? The only angles on a right triangle you're looking for are between what? Are what values?
0 and 90.
Yeah, between 0 and 90. So you're only talking about literally from here to here. Oops, you can't see the graph I'm pointing to. From here to here. Inverse sine, though, only works from negative pi over 2 to pi over 2.
I agree.
So, let's turn the page. Graphically, they'll write it as, or I should say algebraically, they'll write it one of two ways. They'll either write arc sine or inverse sine. They mean the same thing. Okay? But the graph ends up looking like this. It starts low at negative 1, negative pi over 2, goes up through the origin to 1 and pi over 2. Okay? They're literally just reflecting it over the line, y equals x. But then they're just kind of chopping off all the excess. Anywhere it would start to repeat. So, summarizing all that, as far as arc sine goes, your domain is from negative 1 to 1, your range is from negative pi over 2 to pi over 2. It's just the opposite of sine over that same time period. Okay, and they'll write it like this most of the time. Because honestly, that sine with the negative 1, we write it a lot because it's what shows up on your calculator. But arc sine is easier to not screw up mentally when you're doing the problems. So they'll usually do arc sine. I don't care which method you do. Anyway, if I want to find the exact values, I'm going to think about what this corresponds to when I'm dealing with sine. Arc sine of negative 1 means the same thing. It's looking for the angle value that gives you negative 1. So what this really means is sine of some value of theta is negative 1. Now, since I'm only looking at the right half of the graph here, I'm only looking from negative pi over 2 to pi over 2. Where is inverse sine of negative 1 going to be? Negative pi over 2. And you cannot say for those 3 pi over 2. Okay, it has to run from negative pi over 2 to pi over 2. What about inverse sine of 1/2? Where will that be? Do a lot of unit circle stuff right here. Pi over 6. Is this going to occur at square root of 3 over 2 and 1/2 when sine is 1/2? Well, that's right here, pi over 6. What about inverse sine of square root of 3? Anybody? That's a harder one. Go and punch in your calculator, see what you get.
There should be a radians, right?
Yeah, pretty much, unless it says degrees, you're in radians. What do you get? Why would you get error? What do you mean? Yeah, it's greater than 1. If I was thinking about this in terms of sine instead of inverse sine, this would be your output value for sine, since it's input for arc or for arc sine. Square root of 3 doesn't fall within that curve, that sine wave. So this one is no solution. When you're talking about arc sine, arc cosine, the input values cannot be bigger than 1 or smaller than -1. Okay? Questions on those? All right. Yeah, undefined, or I usually just draw the empty set, same difference. Either way. What about this? If I want to sketch a graph of y equals the arc sine of 2x. Well, how's that 2x going to affect the graph? Shrink it how? Shrink it horizontally. It's inside the function with the x. You're multiplying by 2, so it's going to behave in the opposite manner. It's going to affect it horizontally, and it's going to shrink it by a factor of a half. So if I were to draw this, now the vertical is not going to change. Now the vertical here is what was horizontal on sine. So the vertical here is going to go from -π/2 to +π/2. The horizontal now did go from what to what? -1 to 1. So now I just have both of those. So it's going to go from -0.5 to 0.5. The idea being it's going to hit both of those. It's going to come up from there, go through the origin, and hit that. Honestly, when I'm drawing that, I'm usually thinking about, I almost think I'm drawing tangent, because it looks kind of like it as far as the way the slopes work. Okay? When you deal with arc cosine and arc tangent, though, it behaves a little bit differently. Why would arc cosine's range only go from 0 to pi instead of -π/2 to π/2? Arc sine and arc tangent both have -π/2 to π/2 for their range. Why would arc cosine only have 0 to pi? Yeah, if I look at cosine, if I just draw a regular old cosine, from -π/2 to π/2 is going to look like that. Sort of. Right? This would fail the horizontal line test. So what they do instead is they go from 0 to pi. Because from 0 to pi, cosine has no repetitions going on. What's tangent going to look like if you're going from -π, or inverse tangent, if you're going from -π/2 to π/2? Think about regular tangent. What does it have at -π/2 and π/2? Asymptotes, vertical asymptotes. Those vertical asymptotes, when you flip it over the y equals x line, become, yeah, you're flipping them so they turn this way. So now you have horizontal asymptotes. So the idea is they get rid of all the duplicates, but this thing runs forever along its domain, because tangent, even from -π/2 to π/2, has a range forever. So now the range for tangent is anything. Okay? Graphically, they look like this. Arc cosine and arc sine both terminate at those points. They cannot go past. Tangent, though, just keeps running left and right forever. Okay? Honestly, I don't think of these graphs too much unless I have to deal with the graph directly. I usually always equate it back to the unit circle or to triangles. Okay? So if I have a problem like this, arc cosine of square root of 3 over 2. On the unit circle, because you're going from 0 to pi, you're only talking about what part of the unit circle? First and second quadrant, the top half, right? So arc cosine is just dealing with this. I have square root of 3 over 2 here, right? What's arc cosine of square root of 3 over 2 going to be? What quadrant are you in first? The first quadrant. So square root of 3 over 2 is going to be where? 5/6. You're further away along the horizontal, so it's going to be at this one. What about inverse cosine of -½ What quadrant are we there? 2. And which one are you going to be? This or this? Because I know I'm not in the middle. Yeah, it's going to be this one because the horizontal distance is shorter than the vertical. So 2 pi over 3. Now for arctangent, tangent we're talking about what half of the graph? Of the unit circle. The right half, first and fourth, just like we did with sine. Going from one asymptote to the other. So what's the arctangent of positive 1 going to be? Y pi over 4. Right, and since they're both square root of 2 over 2, square root of 2 over 2 divided by square root of 2 is, square root of 2 over 2 is 1. Tangent of square root of 3 over 3. This one mentally, if you're not really comfortable with tangent, I always rewrite this as 1 over the square root of 3. Because if you have 1 over the square root of 3, I know this isn't going to come from 1 of the pi's over 4 because that's square root of 2 over 2 and square root of 2 over 2. To get square root of 3 over 3, the square root of 3 on the bottom like this means you would have to start with 1/2 on the top and square root of 3 over 2 on the bottom. Now if you're doing tangent, where's that going to be at? Pi over 6. Because the sine value, remember, it's tangent sine over cosine. Sine value is smaller than the cosine value. The horizontal's smaller than the vertical. And since I'm using the right half here, well, horizontal further than the vertical means you're going to be there, which is pi over 6. Questions on those? Okay. Go ahead and use your calculator. Find these 3 solutions. While you're doing that, which one's not going to work? Just why would C not work? Yeah, it's smaller than -1. So this one immediately won't work. What do you get for arctangent of 4.84? 1.37. 1.371 or 2?
No, it was 1.36 something.
6 something? 6, 7, okay. Arc cosine? What do you get for that?
1.605. 6.
606? Anybody else get that?
I got 1.9.
Oh, you had. Because I put in the wrong number.
So what do you get? 1 point what?
927.
927? That sounds a little better. 1.927. Were you in degrees or?
I put a 0.
Ah, okay. That would do it. Okay. Now, because of these inverses, this is the main way you used them prior to now. Okay? Anytime you did inverse sine, you were basically trying to find some theta value, some angle, right? You do, if you have sine of x equals 7, you do inverse sine of both sides. And that works when you're talking about just right triangles. The problem is when we expand this to more than just a right triangle, you've got to think about what your limitations are. If I have sine of the arc sine of x, that equals x if x is between -1 and 1. That's the only time this will work. Because if you plug in anything bigger, the arc sine fails. But you also have other limitations. If you're doing arc sine of the sine of y, in order for this to work, it only can work for between -pi/2 and pi/2. Calculator may still spit out an answer, but it's only going to work if you're in that limitation. Cosine has the same types of limitations, tangent the same as well. So you got to always remember to compensate for that. So if I have something like this, tangent of the arctangent -14, this will work because arctangent's domain is everything, all reals. So that answer is just what? Once you know it works, don't make it too hard.
Plug it in.
No, without the calculator. -14. Because I can plug that value in. What about sine of the arc sine of pi?
Doesn't work.
Why? Well, it's greater than 1, actually. For remember, inputs on arc sine or arc cosine have to be between -1 and 1. So this one does not work. Cosine of the arc cosine of 0.54. Well, the input has to be between -1 and 1 for arc cosine, so that works. So your answer would just be 0.54. So it's just a matter of determining whether it works or not, and then plugging it in. Okay. Now the other nice thing here is you can actually figure out some kind of bizarre combinations. Okay. Now for these, its exact value, unless it asks specifically for approximate to 3 decimals or something like that, it's assumed to be exact value. For this, cosine of the arctangent -3/4. Well, I'm going to cheat a little bit. Because what this means is tangent of theta is equal to -3/4, right? Now, arctangent only works in which two quadrants? 4 and 1. So I'm going to think about this in which one of those, since this is -3/4. Would it be 4 or 1? 4. Because tangent is negative in the fourth quadrant. So what I'm going to do for this, tangent is what over what in general? Sine over cosine or opposite over adjacent. Now what I'm going to do here is I'm going to cheat. I'm going to use the right triangle to figure this out. Because if this ratio holds true, where you have 3 over 4, that means I'm going to go 4 out horizontally and 3 down vertically. Okay, so I have 4 and -3. That's opposite of this angle over adjacent. What would the hypotenuse of that be? 5. Because once I have that, now I can figure out what cosine would be. Cosine of whatever angle this generates, I don't care what the angle is, would be what over what? Would be adjacent over hypotenuse, 4 over 5, yep. So that'd be 4/5. Now admittedly, that one you could actually type into the calculator, it would give you 0.8. One like this isn't being quite so nice though. Arc cosine of 2/3. Well, which quadrants am I talking about for this one? 1 and 2. Arc cosine narrows it down to 1 and 2. Because you're doing it of a positive number, it narrows you down to 1. First quadrant. So, cosine is what over what? In general. Adjacent over hypotenuse. So if I draw my angle, I don't care where here. I'm going to do, the hypotenuse is 3 units long. The adjacent to this angle would be the horizontal, is 2 units long. And then draw the vertical up to that point. So it generates a right triangle. Now if I want sine, what do I need to find? The opposite. The opposite here would be what? Careful. Square root of 5. Because the hypotenuse is 9. You subtract those. If I was trying to find the hypotenuse, then I would add. So you take 3 squared plus or minus the 2 squared, gives you the square root of 5. Okay? So then if I'm doing sine of that, what am I going to get? Square root of 5 over 3. That would be your answer. Do those make sense? Okay. Now, this one, if you were to plug it into the calculator, would give you some weird decimal. It would not be an exact answer. There's no good way to convert to 1 from there. They will also give you some that are a little bit more creative. This one doesn't even have numbers in it. But it's the same type of problem. Write an algebraic expression in terms of x for secant of the arctangent of x. Well, the problem is, first off, I need a fraction there, right? I need to have tangent is what over what? Opposite over adjacent. So, what I can do for this is rewrite x. X is x over what? 1. So what this is saying is the opposite side of this triangle would be x. The adjacent side would be 1. Now, you don't know what quadrant it's in, but you don't actually care at this point because the x is going to be limited by that. But since they're just asking for an expression in terms of x, I'm just going to draw a right triangle. I'm going to put theta here. Where's the x go? On the opposite, which is the vertical leg. Where's the 1 go? On the horizontal leg. The hypotenuse then would be what? Close.
Square root of x
Square root
squared.
of x. So then they're asking for secant. Secant, well, which one is that reciprocal of? Cosine. And cosine is, so secant is hypotenuse over adjacent. So what's the hypotenuse?
Square root of x squared.
Square root of x squared plus 1 over 1. So my answer is square root of x squared plus 1. They're going to be pretty answers, but it's getting used to the algebraic manipulation on top of everything. So it allows you to generalize to many more situations. So for this one, where would I start if I want to do the tangent of the arc cosine of 2x? Make a right triangle. Yeah. The 2x here, cosine is adjacent over hypotenuse, so 2x is your horizontal. And
And then 1.
1 for the hypotenuse. So then the other side is going to be what? Square root of 1 minus what?
2x squared.
So you square the hypotenuse and subtract 2x squared. What's 2x squared? You gotta be careful in the way you're thinking about it. It's 2x in parentheses squared, right? So what is that? 4x squared. Because you're squaring that whole side, right? You can't just square the x, you gotta square the 2 as well. So then when I do tangent, tangent is gonna be what? Over 2x. Now does that simplify?
No.
Why?
Everything's under the radical.
Well, it's not just so much that it's under the radical, it's that minus sign means you can't simplify anything. Under the radical, you might be able to simplify. If it was like 75x squared. Okay, but because that minus sign means you're not going to be able to peel things apart enough to be able to simplify it all. Okay. Radical of anything where it's plus or minus under it, you're pretty much stuck.
Get it?
Questions on any of it? Okay, this is bizarre enough that these kind of last couple problems are bizarre enough you want to play around with it a bit, okay? There's a reason we're giving you 2 days on this. Use it.